But I'm glad it sounds because I feel like they like sound better. But I had to like take out me too. Like I have like those nice little effects, however, I didn't take it out. My mom was like, what is this?
Did anyone go look up what a Calc was? What is it? He's a short, fat kangaroo. They're mean. But they look really cute. You want to look up a Hyrax? And pikas, they're pretty cute. Pikas are like
You know the equation to one. Okay.
All right, so just hitting some highlights here of, okay, it's been a while. Yeah, product rule, and it's weird, it's high. Midterm in 2 days, Scantron, I believe it's 25 multiple choice. So no, I don't care to see your work. I'm not looking at anything but the bubbles. It's my favorite day of the year. I go skipping on down the lobes and they're grading in about 30 seconds. I love it. Which actually, it's a lie. It never actually works, and then it takes me like an hour to get the machine to work right and all the misfeeds. But whatever, it's still graded a lot faster. And it will be scaled to be a real test. So tests are generally about 30 or so points, so this is going to be 30. Cool. And does anyone remember derivatives? People getting to the midterm review and they're like, wow, it's been a minute. Product rule?
Well, I think I found you in the product.
Okay.
So pi times x to the power of pi minus 1.
So first times the derivative of the second, the derivative of the second.
It's
That's a weird one.
what? No, I didn't. Oh. No.
Okay, so if it was e to the x, it would be e to the x, but it's pi to the
Pi
x.
to x to the pi to the power of x minus 1.
Nope.
What?
So
That's not how it works.
it is actually plus second times the derivative of the first, x to a number. So the way we've done those is multiply by the power, lower the power. And if it's hard to see because that pi is so irritating, if I was to pick a number instead of pi, 2. The derivative, first times the derivative of the second, 2 to the x times natural log of 2, plus second times the derivative of the first multiplied by the power, lower the power. But x to the pi is weird. And the AP exam does like to ask you things that look annoying. And 2A, I didn't intend that for today, but oh well. Suggestion? How do we split sine 2x? Okay, so trig identity from the past. We haven't used it in a super, like since September kind of time. How's that gonna help? U substitution. Okay, what's the U value, Cecilia?
Cosine.
Sine x, cosine x, what's the U value?
Oh, cosine x.
Cosine squared.
Yeah.
Often it's the exponent. What is the derivative of that? Multiply by the power, lower the power, and multiply by the derivative of the stuff inside, which is a negative sine x. And Eitan said we can change sine 2x into this, or I could change this it doesn't matter which way you go. But 2 sine x cosine x is sine 2x. This had a negative, that has a negative. Okay, so translating, that becomes e to the u, and it's negative. And I need to change when x is 0, cosine of 0 is 1, 1 squared is 1. When x is pi, cosine of pi is negative 1, but negative 1 squared is positive 1. So what is it? Zero. So I don't even have to continue. Integrating at a point. Did I do something wrong? Yes? I mean, it's early. Good. So that one comes out to 0. But part B, A, when u is pi over 2, cosine of pi over 2 is 0, 0 squared is 0. Okay, now that one we actually have to do the integration. Molette, how do we integrate e to the u? It's just itself, yeah. So, negative e to the u. E to the 0, it's not 0. What's e to the 0?
1.
1. Okay, so that becomes negative 1 minus plugging in the 1. So e minus 1.
Good morning, BCC. This is a reminder that today we have a special schedule. We have the electives fair downstairs in the atrium, and then we also will have the EOS survey for everyone to complete. So as you report to your English classes and after attendance has been taken, please come on down with your classes to the elective fair. Thank you.
Questions? Yeah.
I was doing the derivative of I to the u any different than like I to the u, for example. Like they have different answers, but why is that when it's just like two numbers?
Okay. And I don't stress these very much because the AP exam doesn't. But, all right, guys, from section 3.8. E to the u begets e to the u. The derivative of e to the x is e to the x. 3 to the x, it's an imposter. It's close to e, but it's not e. It needs a little conversion factor. That's all. And I proved it in class where this comes from, and I can show you again, but I'd rather spend time differently. And in the land of get a minute, parametrics. We did that for a matter of like 5 minutes. It's not hard, but just reminding you. X is sine t. y is 5 tangent t. What is dy dx? Note there was no t in that. So Jasper, what do I do? Okay, well, like intuition. You got it?
So you do dx dt and then dy dt, and then you divide them by each other, and then you get dy dx.
Okay, what is dx dt?
Cos of t.
Cosine t. And dy dt?
5 secant squared.
So she said, find a change in x with respect to time, change in y with respect to time, and then she said, do dy dt divided by dx dt. When you divide by a fraction, it's multiplying by the reciprocal, and she's right that we'd get dy dx. So, taking these two things, dy dt over dx dt is 5 secant squared t divided by cosine t. So dy dt, or dy dx is 5 secant cubed, or 5 over cosine t. Ethan, you don't look like you agree with that.
I did dx divided by dy.
Yeah, and that's really, really easy to do. So be careful that you put the change in y over change in x. And when I solve these, I generally write out my work. I do the dy and then I do the dt immediately under it so that I don't mess it up. Okay. Okay. Midterm review, good times, party. Just because I know where we're going. Limit definition of derivative. It's been a minute. Chapter 2 was a long time ago. But the idea of those, we wanted to find the instant rate of change, and the way that we do that, we can't find the difference of stuff between a point and that same point. So they cheat. They're like, oh, I'll pick these two random points, but then they slide this point on top of that one. How do you do that? You end up doing 0 divided by 0, which, please don't tell me that's 0. But here are these different kinds. This is the general one, and these two are definition of derivative, and this asked for a random point because it's harder to see when it's a variable. Like at 2, what's the slope at 2? Well, find the function at 2 plus a little bit minus the function at 2 and divide by the change in x. So change in y over change in x. And then slowly make that go away. For those of you who did these, this one, you probably just expanded, reduced, and you got 6. But it's x squared, the derivative of x squared, evaluated at 3. This is the way your calculator works. It says you wanted the derivative at 3. Okay, take a smidgen this way, take a smidgen that way, forward and backwards, and that's how it inaccurately does slopes of absolute values at their corners. It's like it's 0 because it averaged out. Okay.
So stupid.
Yeah, well, the point of this, they're not asking you to do sine A plus B and expand that and remember that formula from pre-calc. They're asking you to recognize that this is limit definition of derivative. And I said earlier today, this exact question has been on the multiple choice of the AP exam more than once. What function does it look like we're doing the derivative of? Looks like sine. So what is the derivative of sine? Cosine, yeah. And where does it look like they want us to evaluate that? Pi over 6. So what is cosine of pi over 6? Root 3 over 2. So they're not asking you to do all the expand and smush. They're asking you to recognize limit definition of derivative. This one we could have done a couple of ways. This one is also limit definition of derivative, evaluated at wherever a is. So what does it look like the function is? Square root. Derivative of square root, multiply by the power, lower the power, and then it looks like it's asking us to evaluate it at a. We actually did this problem in class, and someone in here, I don't remember who anymore, factored this denominator as difference of squares. They don't say squared on it, but we can force that x is root x squared, and a is root a squared. Opposite signs, reduce those, now plug in the a. I have 1 over square root of a plus square root of a. I get the same thing. There are options. This is the hardest one on here. And by on here, I mean the whole 2 pages of all of the review. That one is also limit definition of derivative. What's the function? E to the x. Derivative of e to the x is e to the x, and it's asking you to evaluate it at 1. So it'll come back to be e. So limit definition of derivative could have been used to evaluate those guys. Those of you who know L'Hopital's, haven't taught that yet, but you can use it. It's like having a loaded gun and not knowing how to use it. Yeah.
How do you know what the function is for the one that you circled in green that wasn't?
Looking at the pattern. That one, honestly, I would just expand. It is what I did, and I was like, oh yeah, this other way works too. Okay, so I wanted to show those guys because those were the super tricky ones. But otherwise, Camden, do you remember how to do B? Like evaluate that thing? No?
Oh, I don't know you.
Well, what?
It's like pull it apart.
Okay, yes, pull it apart. How?
I don't like it's really take the 5x and the like sine x.
Which one? Is it, do I take? So yes, I agree. Pull it apart. Remember, what is anything? Remember that x is getting frisky with the 0, x is approaching 0. Frisky. Sine language, sine x, sine language of x, over x. As x approaches 0, Sine x over x goes to weird number one.
Yeah, there's.
Yay, Maya. Working in an NGO in DC. Okay, so. Excellent. So pull it apart, x over sine x, as well as the reciprocal of that. Either of those, as x goes to 0, that's going to be 1. And cosine of 0? Not 0. Preston, what's cosine of 0? 1. So that goes to 5/3. Do you guys remember the Ellie rule? Sophie, what's the Ellie rule?
It's like if there's like sine of 3x over cosine of 4, it's like if you can take out the signs and then it ends up just being like the stuff inside of it over like the stuff on top. It doesn't make any sense, but like yeah, so it'd be 3x over 2x. Perfect, yeah.
So we don't need to show any work for these. It's unfortunate. But how this works, if it's in the pattern of sine A over A, or the upside down of that, those go to 1. So, just to quickly show you where that comes from. Multiplying by 3 over 3. So I move this 3 over, I'm going to move that 20 out. That's 1. So 3 over 20 comes out. Okay. What do you guys want to go over? There's a whole lot of questions.
Can you do like one from each like type?
Okay, like what?
Like the first one's are limits and then the second one like the numbers.
Like number 3 is, I mean, hopefully number 2 is easy. Like which one's continuous? Well, there's a divide by 0 when I plug 1 in, not continuous. Can't do log of 0, that's not continuous. That one's fine. These guys, all very different kinds of derivatives. So I did review parametrics. As Brooke said, do the derivative of x with respect to t, derivative of y with respect to t, and put the change in y over change in x, and there you go. Logarithmic differentiation, always a party. This is product rule with a lot of chain rule. That one's always important. It's fundamental theorem of calculus. How do we do the derivative of the integral? Sydney, how do I do this one? Okay. So Sydney said you plug in the bounds.
You plug in the top bound for t, the first one, and then minus the bottom bound for t.
Okay, there's something else though. So yes, the derivative of the integral, they're inverses, so you just get the inside stuff. Sort of like the square root of x squared is x. However, sometimes multiplications happen. So this is going to be 1 over something squared plus 1 to the 2/3. What is that something? So I need to write that top bound, but I need to do chain rule. I need to also then multiply by the derivative of that top bound, derivative of cosine, negative sine. The second piece, I'm not even going to fill it in because stuffing in pi for t and then multiply by the derivative of pi. What's the derivative of pi?
1.
0. It's a constant. So when I multiply this by 0, the whole thing goes away. So really, I only have that. Right? Do you remember this? Oh. Derivative of arctan, you guys are pretty good with by now, right? 1 over 1 plus stuff squared times the derivative of stuff.
Yeah.
Yeah. Okay.
Wait, can we go over 5D?
5D.
I don't understand what G is here.
The function g, like its integral over 0 to 5 is 5, but
At some point, I click across.
what if it did that? Like hit 0 a whole bunch of times. Actually, it doesn't even need to cross. What if it bounced and hit 0 a whole bunch of times? So g of x could be 0, so we technically can't evaluate that. Number 4, the point of number 4 was for you guys to have an appreciation of order of operations when you do the derivatives, how things work. A prime of x, derivative of the outside, leave the inside alone.
Shit. Today's gonna be the day that died.
Good time. Just keep in mind, y'all registered for the class. This one is just saying, take your answer from part A and plug in 2. So f prime of 2 squared plus 1 times 2 times 2. Part C is also saying, take your answer from A and plug in x cubed. So it's f prime of x cubed squared.
Fix the power 4. No!
Times
What? It's not x to the power of 6, x to the power of 4.
Amir, what are we plugging in?
X squared.
Sorry,
Oh,
that's
yeah.
a cube.
Oh, okay. I couldn't see it. Am I just going blind or something?
I'll go with times something. Okay, but D is different. How is D different?
Oh, it's the derivative of this is G prime x.
Plug in the x cubed first and then.
Okay, this one is plug in the x cubed first. So G of x cubed is f of x to the 6th plus 1.
You think it's 2. I can't. My reading, from this distance, I can't really
Hey,
determine.
technically, you do have a copy of this paper, and yes, it was handed out way back in December, so you could have a copy on your desk.
No.
Because I agree, it's tiny. Okay, so if this is g of x cubed, the derivative of that, derivative of the outside, and then times the derivative of the stuff inside. So they look similar, but they're different. So it depends on when you're doing the derivative. Do you plug in the stuff before or after? Guys, make any sense or? Okay. Anything else from this page? These are just the rules, seeing if you can apply them or not. Keep in mind, even functions, they end up being doubled when you go symmetrically around the axis. Odd functions cancel each other out. We love integrating odd functions from negative a to a because the answer is always just 0. I don't care. You guys remember implicit differentiation? No? Okay. Then let's look at number 11.
A, B, C, D, E, B, B, B. I don't believe that anybody.
So try number 11.
This is on this one, but on number 13, it asks for like its maximum. It asks for its maximum and then rather than asking for the absolute.
Okay, someone just asked, there's a question evidently on this page that says, where's the function's its maximum? It is implying absolute. When it says, what is its minimum? Yeah. So step 1, you can't isolate y, so you need to do the derivative of all of those things with respect to x. Derivative of x squared multiplied by the power, lower the power, and then the derivative of the stuff inside, change in x with respect to x is just 1. Then we get to the dreaded product rule of x, y. I left the 4 on the outside. In hopes that I wouldn't mess something up. One of the bigger mistakes that people make with these, you do all the implicit stuff right, including the complicated product rule, and then you forget the derivative of the constant 3 is 0. So here I need to factor a dy dx out of one group and move everybody else over. Nick, what?
Why did you keep the y in the parentheses? There will be x, dy dx plus y. It does not
Why?
that, like, when you take the derivative of that y, and that's dy dx. And go back.
Okay. So if you want to see this as, my first term is negative 4x. So, all right, negative 4x times the derivative of the second plus the second times the derivative of the first. What is the derivative of negative 4x?
4. Negative.
Negative 4.
Yeah.
Doesn't matter. Luke, should I move the dy's to the left or the right? Leave them where they are and move everybody else over? Okay. Luke has spoken. So I am going to add the 4y to both sides and subtract the 2x from both sides. The stuff that's left over has dy dx on them, so dy dx equals 4y minus 2x over 2y minus 4x. Just factor the 2 out. But there's implicit. All right. This is an old AP question that came from a free response. And the second part of the question says something about where does the function have a horizontal tangent or a vertical tangent? How do I find? Let's just go with horizontal. Massimo, what has to be true when this is a horizontal tangent?
The derivative equals 0.
So where does dy dx equal 0? Okay. When that numerator is 0, and on the AP exam, students who left it there, whenever x equals 2y, you're not done. They actually wanted you to find coordinates. They wanted you to go back and say, okay, x equals 2y. And turns out there is no y value on these, and there's no there is no coordinate that makes them horizontal or vertical, because there's a perpetual typo in the question that I keep not fixing. But they wanted you to go through and actually find it. All right. Please look over the rest of the review, whatever you guys have questions on. We'll cover tomorrow.